Alright, this is the last video for the exam for review. This is problem number 15 we're going to start with here. So it says, how long will it take an investment to double if it's invested in a certificate of deposit that pays 7.84% annual interest compounded continuously, round to the nearest tenth of a year? So first of all, our interest rate as a decimal is 0.0784, and notice we're compounding continuously here, so we're going to use the PERT formula. Now, it doesn't tell us how much money we're going to be working with here. It just says we're going to double our investment. We want to know how long it takes. So basically, whoops, let me change colors. We're looking for t. So let's go ahead and let our principal be $1, just to make things easy. That means that A would equal 2, so that we double our money. So let's plug in those numbers. And you can see that we need to solve for t. That's our only variable here. And so I'm going to rewrite this without the 1. I just switched sides as well. So this is exponential form. It's got the 3 parts: base, exponent, answer. Let's go ahead and switch forms. And so the only thing left to do here is to divide by 0.0784. And when you put that in your calculator, you should get 8.8412. But it said round to the nearest tenth of a year, so that's going to be 8.8 years. Now notice you could check this problem by just plugging in 8.8 for t, and if you do that, notice I've rounded a little bit, so it might be a little bit off, but it should be at least relatively close to 2 when you plug that into your calculator. Let's go ahead and look at number 16. So it says the number of bacteria N of t present in a culture at time t hours is given by this equation. So first of all, what is the initial number of bacteria? Well, this is in the form A equals A naught times e to the kt power. This is our growth or decay formula, where we said A naught is the initial amount. By the way, K is the growth factor as a percent or a rate. We can write it as a decimal as well, and T is time. And so in this problem, our initial value is 10,000. You could also plug 0 into the function and you would get 10,000. So that tells you the number of bacteria that you initially have. How many bacteria are present after 4 hours? Well, T is the number of hours, so it's 4 here. We're just going to find N of 4. So I just plugged that into the equation there, or into the function. And when you put that in your calculator, you should get 918.25. But remember, these are bacteria, kind of like people, except, I mean, obviously different, but you can't have 0.25 bacteria. So we would round this to about 14,918. All right, let's look at C. It says, when will there be 50,000 bacteria present? So basically, I'm going to go ahead and do my work over here. Basically, N of t is 50,000. That's what I want to know, how long it takes for this 10,000 bacteria to grow to 50,000. So I'm going to go ahead and put 50,000 into the formula for N of t. And you can see we need to solve for t here, and that, notice it said when, so we're looking for how long it's going to take, or the time. So in this problem, we want to get rid of the 10,000 first. And so notice now we have the 3 parts: the base of e, exponent, and then the answer of 5. And so we can switch this to logarithmic form. We get natural log of 5 equals 0.1t. Let's divide by 0.1. And when you put that in your calculator, you should get 16.09. So that's about 16 hours. Notice again, time is in hours. All right, letter D, how long will it take for the number of bacteria to double? So this is similar to what we did in number 15. So if we're starting with 10,000 bacteria, the amount would double if we got to 20,000. So we're going to set it up similar to C. So here's our original formula. We're going to make n of t 20,000. That's going to show the bacteria doubling. And so now we need to solve for t. So just like with the last one, we're going to start by dividing by 10,000. And so now we have an exponential equation with the 3 parts. And anytime you have a variable in the exponent, you're going to need to change forms. Let's change that to a log and divide by 0.1. And when you put that in your calculator, you should get 6.93, which is about 7 hours. All right, let's move on to number 17. So it says radioactive strontium decays according to this function here, where time's in years and A of t is the amount in grams. So what's the initial amount of radioactive strontium present? Well, that's our A naught, that's the 5 there. And notice it did say that this is A of t is the amount in grams. So we're dealing with an amount in grams. So we started with 5 grams, that's our initial amount. It says how many grams will be present after 20 years. So they're telling us what t is here. So really we're just finding A of 20. So I'm going to plug that into the function. And you should be able to put that in your calculator and you get about 3.1. So it'd be 3.1 grams. So notice it is decaying. We have less than what we started out with. Let's move on to number 18. It says an endangered species of fish has a population that's decreasing exponentially according to the equation A of t equals 14,000 times e to the kt power. So it says A is the fish population t years after 1990. So this started in 1990. The fish population was 14,000 in 1990. I'm going to go ahead and write our formula down here. So notice t is your time in years. A naught is 14,000. Again, that's what you started with at this time that we're starting, 1990. T is 9 because it says 9 years later. It was 12,000. So that's going to be our A of t. It says use this information to find k to 4 decimal places. So we've been given everything in the formula except for k. So we have to find k. So when you plug in the numbers, this is what we're solving. We're going to need to divide each side by 14,000. On the left you get 6/7, and on the right we're going to have e to the 9k power. And so you have base, exponent, answer. You've got your 3 parts for an exponential equation. And let's go ahead and switch to log form. And the only thing left to do here to get k by itself is divide by 9. So when you throw that in your calculator, you should get negative 0.0171. It's about 1.7%, negative 1.7%. And again, notice it's negative, which indicates that the population is decreasing. And that's the end of this video and the end of the review. I'm not going to worry about number 19 if it's not one that I would put on the test. And you can look at the solution that I've written up on the answer key. And that's all for the review.